Hello dear students, welcome to Physics Focus YouTube channel. So continuing with our series of PYQ, today we will be discussing NLM PYQ from January 2024 attempt. Before this, we have discussed ray optics and kinematics PYQ of January 2024 attempt. So the link for the videos you can find in the description box. Also on our channel, you can find revision videos for these chapters. Right, before solving PYQs, you can go through the revision videos and then further proceed. So let us start with this video. Yeah, so the first question that we have, it is your 27 January shift 1 question. It says a body of mass 1000 kg is moving horizontally with a velocity of 6 meter per second. Fine, let's draw the situation. 1000 kg body moving with 6 meter per second. Fine. If 200 kg extra mass is added, the final velocity is okay. So let's see. So during the process, during its motion, extra 200 kg has been added. That means total mass now will become your 1200 kg. So what is the velocity now? How to deal with it? Basically, this is a question of your linear momentum conservation. No F external is acting, the mass has been dropped, so F external 0, so momentum will be conserved. Delta P will be equals to 0. P initial is equals to P final. Let us see initial momentum. What is our initial momentum? 1000 into 6 is equals to P final, that is 1200 into the velocity. So we can see over here, cancels out. V value comes out to be 10 by 2, which is 5 meter per second. Right. So answer for this is 5 meter per second. Let us check the option. Which option we have? Option number 4. Option number 4 is our correct answer. Let's look at the next question. Yeah. Next, a theoretical question. Two statements are given. Let us check which is true and which is false. Right. Statement 1 says the limiting force of static friction depends on the area of contact and independent of the material. Let us see what is our static friction value. We write the limiting friction, that is maximum value of static friction. So friction limiting is mu s into n. Now beta, mu is coefficient of static friction which depends on the nature of material. Which depends on nature of material, that implies this statement is wrong. Statement 1 is incorrect. Fine, right? Also, it does not depend on area of contact. Your friction depends only on the material and the normal force. It does not depend on area of contact. So statement 1 is false. Then if we look at statement 2, the limiting force of kinetic friction, basically kinetic friction we know is given as mu k into n. It is independent of area of contact and depends on material. Yes, it does depend on material. Mu is the parameter which tells us about the type of material, right? And n is the force. So it does not depend on area of contact, but it depends on the material. So statement 2 is correct. Statement 2 is correct. Now you check all the options. Option number 2 says statement 1 is incorrect, but statement 1 is correct. So second option will be our correct answer. Okay, next a pulley block question. Let us see. All surfaces shown in figure are assumed to be frictionless and the pulleys and string are light. The acceleration of the block of mass 2 kg is. The figure is given to you, right? Let us draw the FBD first of all. We want to find out acceleration of 2 kg. Let's draw the FBD of both the blocks. So over here 2 kg block, right? It's kept on an incline, angle is 30 degrees. So what will be happening over here? The mg component will be acting 2g sine 30. Well and good. Then tension will be acting in upward direction. Fine, well and good. Next, let us draw the FBD of pulley also. Why we are drawing FBD of pulley? Because the two blocks are not connected directly with one string. Right, two blocks are connected not directly with one string. Therefore, we need to deal with the pulley also. So over here, for pulley, this will be T and this will be T over here because this is the same string. And over here, if T and T upward, it will be your 2T in the lower string. Why? Because pulley is massless, so obviously the forces should be balanced over here. So 2T over here. Next, if we draw FBD for 4 kg, FBD for 4 kg, it will be your 2T upward and 4G downward. Well and good. Let's write down the acceleration part. Let's write the acceleration part. Let's say that this acceleration is A. The acceleration of this one is A1 and acceleration of this is A2 downward. Fine. Now, this is what acceleration will not be same. Why acceleration will not be same? Because the blocks are not connected directly over here. Two different strings are there. Fine. Let's write down the Newton's law equation for this one. For this one, if I have to write it, the equation will be forming T minus 2G sine 30 is equals to 2 into A1. Equation 1. If we write down for 4 kg block, it will be your 4G minus 2T is equals to 4 into A2. Well and good. Now over here we have tension A1 and A2. Three variables are there. We have two equations. One more equation we need. We'll get it from constraint relation. How do we get it from constraint relation? Constraint relation, basically we need to relate A1 and A2. How can we do it? So over here, whatever is the acceleration of 4 kg, same acceleration will be there. Same acceleration will be there for the pulley also. We can apply constraint relation. So what can I write down? Acceleration of pulley is equals to this side. Please see over here. This is your A2, acceleration of this one A2. This side acceleration is 0, right? Because this string is connected to the over here ceiling. So acceleration of this side will be 0 and this side acceleration is your A1. Fine. Let us see over here. What can I write? A1 plus acceleration. So acceleration of pulley, which is your A2. A2 is equals to A1 by 2. Basically, I am using this relation. Acceleration of pulley is equals to A1 plus A2 by 2. Right? Constraint relation on pulley system. I am using this. Right? There are different ways also. I have used this method. Many people do it with tension method also, right? Different relation methods are used. So I have directly used the relation this one. Now, so A2 is coming out to be A1 by 2. Let's see over here. So in this I can write down 4G minus 2T is equals to 4A1 by 2. So this one will get it as 4G minus 2T is equals to 2A1. Well and good. This is equation number 3, we can write it. Now solving 1 and 3, what do we have over here? T is there, so this we can further simplify it. Equation number 1, I'll write it as T minus 2G sine 30. This will be T minus G is equals to 2A1. Okay, this is 1, and this one again, third one, I will reframe it and write it as 2G minus T is equals to A1. Well and good. Let's add them. This is your third one. If we add it, we'll get 2G minus G. This is G is equals to 3A1. That implies A1 is equals to G by 3. Okay. Acceleration of 2 kg block comes out to be G by 3. Now you check the option. Option 2. Option 2 is our correct answer. Let's move ahead. Okay. Next, 30th January shift 2. It's a good question. Let's take a look at it. A block of mass m is placed on a surface having vertical cross section given by y equals to x square by 4. So y equals to x square by 4. As you can see, this is your parabolic equation, right? So if we draw the curve for this one, it will be coming something like this. Y equals to x square, right? Now somewhere over here, a block of mass m is placed. Somewhere over here, a block of mass m is placed. A block of mass m is placed on the surface having vertical cross section y equals to x square. Okay. If the coefficient of friction is 0.5, mu is 0.5, fine. Then the maximum height above the ground at which the block can be placed without slipping is. How to deal with it? So they are asking us how much high we can keep the block such that the block does not slip. Let's say that the height at which we can keep is y. It is y. General, we are taking that it is kept at a height of y. Now it will not slip. So if we talk about inclination, over here some inclination will be there at this y. Some inclination will be there for this particular point. This particular point will be having, if we draw the tangent, this tangent will have some inclination. How do we find out the force, means balancing over here? If we do the balancing of forces on an incline, what we have, let's say M mass block is kept, mg sin theta is acting downward, and if friction has to stop it, friction will be acting in upward direction, and the maximum value of friction will be mu into n, and n is mu mg cos theta. I hope this is okay what I have done. So at this point, wherever we have kept, let's suppose that at a height of y, the block is at rest. This point, the tangent at this point makes an angle of theta. If the block is at rest, that means it does not slip. What is maximum height where we can keep it? That implies the forces should get balanced. The forces should be balanced over here, and the maximum, for maximum height, the friction will be acting is maximum, right? So what can we write? Mg sin theta is equals to mu mg cos theta, right? Forces should be balanced. If we see mg cancel, sin theta by cos theta is tan theta is equals to mu. Tan theta is equals to mu. This is what we have got it. Now we need tan theta value. How to find out tan theta? See, this equation is given to us, y equals to x square by 4. Y equals to x square by 4. In this case, what will be tan theta? Tan theta is basically dy by dx. So tan theta is dy by dx. Over here, tan theta will be dy by dx. So let us differentiate this. What can I write it? Dy is equals to 2x by 4 into dx. So dy by dx comes out to be x by 2. Dy by dx is coming x by 2. That means tan theta is x by 2. From this equation, from this curve equation, we are getting it. Now let us equate it. So x by 2 is equals to tan theta. From our balancing of the forces, we got as mu. So x by 2 is equals to mu. That implies x is equals to 2 mu. X is equals to 2 into mu. Mu value is 0.5. That implies x is equals to 1. X value we got it as 1. We want to find out height. We can do it. So what is it? Y is equals to x square by 4. If x value is 1, that implies this will be 1 by 4. So the height where, the maximum height where the block will remain at rest is y equals to 1 by 4. I hope this is clear, the solution. Let's move to the next question. Let's see the option also. Option number 1. Option number 1 will be correct answer for this. Let's look at the next question. Okay, next question. 3 blocks A, B and C are pulled on a horizontal smooth surface by a force of 80 Newton as shown in figure. The tension T1 and T2 in the string are respectively. Simple question. We do it in our regular lectures, so not a big issue. Let's calculate this. Diagram is there in front of you. Basically, we want to find out T1 and T2. First, what we'll do, we'll consider, I'll draw it once for myself. So we have 3 blocks, 1, 2 and 3. This is 80 Newton, and then you have 2 kg, 3 kg and 5 kg. Okay, and the tensions are T1 and T2. We want to find out T1 and T2 value. Okay, now see over here. So basically, first of all, we'll consider this whole as a system, because acceleration will be same. So we can consider this whole as a system, as a single block, and then find out the acceleration. So F net is equals to m into a, capital M, we can write it, capital M into a. F net is 80. 80 is equals to total mass 5, 3, 8, 8 plus 2, 10 into a. So how much is our acceleration coming? Acceleration comes out to be 8 meter per second square. Now we want to find out T1 and T2 value. So you can apply your second law, F net equals to ma, on specific blocks. So for on block 5 kg block, what will be the equation forming? T1 is equals to, because all of them are going with same acceleration. They are connected directly. They have same acceleration. So T1 is equals to 5 into acceleration we calculated 8. So T1 comes out to be 40 Newton. T2 also we can calculate. For T2 you can apply Newton's second law on this block. So what will be getting? On block of mass 2 kg, we can write down Newton's second law as 80 minus T2 is equals to 2 into acceleration is 8, and F net equals to ma. I am using it. So what we will be getting it, 80 minus 16 is equals to T2. So we get over here T2 value as 64 Newton. So our answer is 40 Newton and 64 Newton. Let's look at our options. 40 and 64. Option number 1. And the options are given such that even T2 was not required to calculate. Options are given such that T2 was not required to calculate. We did it, but without, just because in only first option your T1 is given as 40, remaining all are different values. So anyways, we calculated 40 and 64. So our answer will be your first option. Let's move ahead. Yeah. So the next question that we have, 31st January shift 1 question. It's again a pulley block incline question. Let us see. In the given arrangement of a doubly inclined plane of two blocks of masses capital M and small m are placed, the blocks are connected by a light string passing over an ideal pulley as shown. Diagram is there in front of you. The coefficient of friction between the surface of the plane and block is 0.25. Mu value is given to us as 0.25. Well and good. The value of small m, for which capital M equals to 10 kg, that means this capital M value is given to us as 10 kg. Fine. This is 10 kg is given. Okay. The value of small m for which capital M equals to 10 kg will move down with an acceleration of 2 meter per second square. G value is 10, 1037 is 3/4. Fine. So this capital M is moving down with a acceleration of 2 meter per second square. If this goes down with 10, obviously small m will move, if this goes down with 2, if 10 kg goes down with 2, obviously small m will be moving up with 2 meter per second square, because they are constrained to move together with same acceleration magnitude wise. Fine. Now how to deal with it? We want to find out small m value. Acceleration is given, we want to find out small m value. Let us draw the FBD first. So if we draw the FBD, this is our 10 kg. What all will be getting on this one? Downward 10 G sine 53, upward will be tension, and because the block is moving downward, friction will be acting in the up the inclined direction. So it will be, friction is mu into n, and n is how much? Mu mg cos 53. So that is mu 10 G cos 53. Fine. Now FBD for this small m. FBD for small m, mg sine 37 will act down the incline. Tension will be acting up the incline, and because the block is moving in upward direction, the friction will act down the incline. And how much is the magnitude? Mu small mg cos 37, and mu into normal, which is mu mg cos 37. Fine. Let's apply F net equals to ma on 10 kg block. So F net equals to ma on 10 kg. How much it will be coming out? 10 G sine 53, that is 100 sine 53 minus tension minus mu 10 G cos 53, that is mu 100 cos 53 is equals to mass into acceleration 10 into 2. Fine. Let's simplify this. 100 into sine 53, 4/5 minus t minus mu value is given to us 0.25, 1/4 into 100 into cos 53, 3/5 is equals to 20. If we solve it, this will be 20, this is 20, 4, 5 times. So we get over here 80 minus t minus 15 is equals to 20. 60, 60 minus, so T value comes out to be 45 Newton. The tension comes out 45 Newton. The tension in the string is 45 Newton. Now, using this tension, we'll apply F net equals to ma on this small m. What it will be? Upward direction motion. So the equation will be coming T minus mg sine 37 minus mu mg cos 37 is equals to small m into acceleration is 2, right? So let's simplify further. T is equals to mg sine 37, I am taking all that, sine 37 is 3/5 plus mu value 1 by 4 into mg into cos 37, 4 by 5 is equals to 2m. Sorry, this is plus only. So if we solve it, this is 2 times, then again 2 times, 4 cancel. So T is equals to 6m plus 2m plus 2m, right? T, tension we already calculated, 45 Newton. So 45 is equals to 10m, that implies m is equals to 45 by 10, which is 4.5 kg. 4.5 kg is our answer coming. Let's check our option. I hope it's visible to you over here. Sorry. Now please check it. This is the calculation part, hai na? So 4.5 kg, that means option number 2 is our correct answer. Let's move ahead. Yeah. So the question we have is, a light string passing over a smooth light pulley connects the two blocks of masses m1 and m2 vertically. If the acceleration of system is g by 8, then the ratio of the masses is, fine. Acceleration is g by 8. Let's see. So this is the situation, very standard problem. Let's say this is m2, this is m1. No. Pulley block system. Can we use the formula? If you know the formula, use the formula. Acceleration for Atwood machine, that is for your pulley block system, what do we write it? m2 minus m1g by m1 plus m2. If you know it, use it. Otherwise, you will have to write down you will have to draw FBT, write F net equals to Mn each block, and then you will get acceleration. Anyways, let's see, very standard formula. Acceleration is g by 8. So g by 8 is equals to m2 minus m1g by m1 plus m2. G cancels out. Let's simplify it. m1 plus m2 is equals to 8m2 minus 8m1. If we solve it, 9m1 is equals to 7m2. That means ratio is coming 7:9. m1 by m2 is coming 7:9, and m2 by m1 is your 9:7. If you look at the options, option number 2 is our correct answer. So m2 by m1 is 9:7. Right? Let's move ahead. Okay, let's see. Next question, it's a friction question. Let's see. A block of mass 5 kg is placed on a rough inclined surface as shown in figure. Okay, let me draw it. A 5 kg block kept on an incline having inclination 30 degree and friction is 0.1 given. Okay. Next it says, if F1 is the force required to just move the block up the incline and F2 is the force required to just prevent the block from sliding down. Okay. So let's draw two situations. F1 is the force required to just move the block up the incline. Now when the block will be having, this 5 kg block will be having a tendency to move up, that means the friction will be acting in downward direction. So if F1 is moving it upward, friction, because the tendency of the block is to move upside, the friction, the maximum friction will be, or static friction direction will be downward. So friction is downward. Obviously mg sin 30 will be acting. So this is your 5g sin 30. Well and good. Next it says, F2 is the force required to just prevent the block from sliding down. Now, what all forces are there? Are mg sin 30, 5g sin 30 is acting down, that is fixed. 5g sin 30 will be acting downward. The block has a tendency to slide down and friction is unable to hold it, because the block has a tendency to slide down, that implies your friction is acting in upward direction. Please understand this. This is the difference will be coming in first and second. When block has a tendency to slide down, friction, the static friction direction will be upward. So friction upward, and it is not sufficient. So which force is required? F2 is required. This is the situation given, and they are asking F1 minus F2 magnet. F1 minus F2. Fine. Difference they are asking. What is the difference in the force? Let's see. So I hope this situation is clear. Now basically let us write down. Both are equilibrium situations only. So now for this, what can I write it? F1 will be equals to 5G sine 30 plus friction. Friction value is how much? Mu mg cos 30. And mu into normal. So friction will be mu into normal, and normal will be normal up, and 5G sine 30, 5G cos 30, 5G cos 30 down. So normal will be your mg cos 30. So in this case, we can write down friction will be mu into 5G cos 30. Fine. This is F1. Let us solve it. So F1 is equals to 50 into sine 30 1 by 2 plus mu value is 0.1, 1 by 10 into 50 into cos 30, which is your root 3 by 2. If we solve it, we get over here 25 plus 5 root 3 by 2. This is your F1 value coming, 25 plus 5 root 3 by 2. Now let us apply equilibrium condition in this case. F net equals to 0 in the second situation for F2. So what we'll be getting? F2 plus friction is equals to 5G sine 30. Okay. So F2 will be equals to 5G sine 30, that is 50 into 1 by 2 minus friction. Friction value is mu mg cos 30. Maximum value of friction. Maximum value of friction will be mu mg cos 30. Mu 0.1 mg, that is your 50 into cos 30 root 3 by 2, right? This comes out 25 minus 5 root 3 by 2. This is what we are getting, right? Now let us do, this is our F1 value, this is our F2 value. So F1 minus F2 magnitude wise, if we do it, so this will come out 25 will cancel, and this will be 5 root 3 by 2 minus of minus 5 root 3 by 2. Now this will be plus. So 5 root 3 will be the answer, right? Answer will be 5 root 3 will be our F1 minus F2. Answer will be 5 root 3. Let's look at our options. Option 5. Now you will wonder why 5 options are given in this, right? Over here our answer for this will be 5 root 3. Actually in the paper, in the main paper, right answer was not there. 5 root 3 is the correct answer, but in the paper right answer was not there. Only these 4, the first 4 options which are shown to you over here, these 4 options were there. The correct option was not available. Therefore this question was means removed, है ना? Basically NTA considered this, and 5 root 3 is the correct answer for this one, right? Let's move ahead. Yeah, next question. Consider a block and trolley system as shown in figure. If the coefficient of kinetic friction between the trolley and surface is 0.04, over here this trolley is there. I have drawn it as 20 kg block, है ना? So this trolley is there. Friction is mu is 0.04. The friction coefficient is 0.04. The acceleration of the system in meter per second square. Let's see. So over here, if we look at the FBD of this, 60 Newton will be acting downward, tension will be upward. On this one, on the trolley, tension T will be there, and backward side friction will be acting. Let's apply F net equals to MA. On this one, what can we write? 60 minus T is equals to 6 into A. First equation. On this one, what can we write? T is equals to, or sorry, friction is also there. Friction is this. T minus friction is equals to 2 into 20 into A. 20 kg is the mass, so 20 into A. So second equation, let's add them, 1 plus 2. So what do we get? Tension cancels out. 60 minus friction is equals to 26A. Friction, let us write down friction value. So friction value will be how much? Mu into N. On this 20G will be downward, N will be upward. So N value is how much? 200 Newton, right? So mu into n, friction is mu into n, 0.04, which I can write as 4 by 100 into n, which is 200, is equals to 26A. Cancels out. 60 minus 8 is equals to 26A. So this comes out 52 is equals to 26A. That implies A value comes out 2 meter per second square. Acceleration for the system is coming 2 meter per second square, right? Application of F net equals to MA, drawing FBD and application of F net equals to MA. I hope you got it. Let's move to the next question. Yes, our next question is, it says a cricket player catches a ball of mass 120 gram moving with 25 meter per second speed. Okay, so mass is 120 gram, its initial speed is 25 meter per second. Okay, if the catching process is completed in 0.1 second, time taking is 0.1 second in catching process, that means V final will be 0. Okay, then the magnitude of force exerted by the ball on the hand of the player is, basically this is a typical question of your second law, simple basic formula, F is equals to delta P by delta T, right? F equals to rate of change of momentum. So force we want to find out, delta P, what we can write, M into delta V by delta T. Mass is given to us 120 gram, which I can write as 120 by 1000 into delta V. Delta V finally 0, initially it is 25. So 0 minus 25, time taken was 0.1 second. So that I can write as 1 by 10. How much are we getting? Okay, so 12 into minus 25 divided by 10. Now you check it. 5 2 times, 5 times, 6 times, 30. Minus 30. Minus 30 because this force is basically your retarding force. Hai na? Magnitude will be 30 Newton. So this is our answer. Yeah. So with this question, we have reached to the end of our video. This is our last question. Let us see. A body of mass 4 kg, a body of mass 4 kg experiences two forces, F1 equals to, in vector form it is given to us, 5i cap plus 8j cap plus 7k cap, and F2 vector equals to 3i cap minus 4j cap minus 3k cap, right? Find the acceleration of the body. They are asking us acceleration. Forces are given to us in vector form. So acceleration will be your what? F net by m, right? F net by m. First of all, let us calculate F net. F net will be summation of these two forces. This will come out to be 8i cap plus 4j cap plus 4k cap, right? So F net magnitude will be root over 64 plus 16 plus 16. I hope it is okay, right? This thing will come out to be root 96. So acceleration is root 96 divided by mass, which is your 4. When we'll simplify this, our answer will come out to be root 6 meter per second square, right? Simple question. I hope it's clear. So with this, we have completed our discussion of NLM PYQ. I hope you found the video helpful. We have also uploaded other PYQs, basically ray optics and kinematics PYQ. You can check them out. In the coming days, we'll be uploading PYQs of other chapters also. So do consider to press the like button and subscribe to our channel. Thank you very much. Bye bye.